Hello viewer, welcome to today's class. Today we are going to study source transformation. We have noticed that series parallel combination and Y-delta transformation help simplifying circuits. Source transformation is another tool for simplifying circuits. Basic to these tools is the concept of equivalence. We recall that an equivalent circuit is one whose VI characteristics are identical with the original circuits. A source transformation is the process of replacing a voltage source Vs in series with a resistor R by a current source Is in parallel with a resistor R, or vice versa. So these two circuits are actually equivalent circuits. So let me name these two nodes A and B. So these two nodes are actually the same two nodes A and B. So let us first consider that we're given with this voltage source and this resistor in series combination. So we want to transform it into a current source. So the concept is actually, if I short this path, then definitely a current will flow through this way. Let me name this current ISC, which is the short circuit current. And as I'm saying that these two circuits are equivalent, so if I short this path, so definitely a current will flow through this way, which will also be the short circuit current. Now as you know that if I short the two node of a resistor, the resistor will actually have no impact on that circuit anymore. So this current Is will now completely flow through this short path, and no current will flow through this R anymore. So I short circuit is simply equals to Is. Now what is I short circuit? I short circuit, from the given circuit we can calculate I short circuit, which is nothing but Vs over R from Ohm's law. So Is is actually Vs over R. So that is one of our finding, that if you want to transform a voltage source to a current source, there has to be a resistor in series with it, so that we can calculate the value of the current source, which is the value of the voltage source divided by the value of the resistor which is in series with it. Okay, one thing is very important here. When you are transforming a voltage source into a current source, always keep the direction of the current source, the arrowhead of your current source, towards the positive direction of the voltage source, so that the direction of your current in both the circuits will remain the same. Okay, now if you want to transform a current source into a voltage source, then the first condition is there has to be a resistor in parallel with it. So we can transform it into a voltage source with the same resistor in series with it. For this case, we have to calculate the open circuit voltage of our given circuit first. So from Ohm's law, the open circuit voltage will be the drop across this resistor. So this current is actually flowing through this resistor and causing a drop Is times R according to Ohm's law. And as I'm saying that these circuits are equivalent, so the open circuit voltage I've found here has to be the same, and which is nothing but Vs. Why? Because as this is an open circuit, no current is flowing through this R, so no drop is causing by this R, so you get simply the source voltage as the open circuit voltage. So this is actually Is times R, because these two circuits are equivalent. So this is another finding, that if we want to transform a current source which is in parallel with the resistor R to a voltage source, then the value of the voltage source Vs will be Is the value of the current source that we are transforming times the register R with which the current source is in parallel. So that's all for today. Thank you very much.